today's session. In this session, we are going to discuss about what is pH and what is pH scale and what is the importance of pH scale in our day-to-day life. Okay. So, with the help of the indicators, we can know whether the given solution is an acid or a base. But the strength of the acid and base cannot be known with the help of the indicators. Okay. So, the strength of an acid and a base is known with the help of pH scale introduced by Sorensen. Who introduced that one? Sorensen. So, pH is defined as the negative logarithm of H plus ions. What is that? The negative logarithm of H plus ion concentration. So, pH scale varies in between 0 to 14. 0 to 14. So, for acids, pH is in between 0 to 7, means less than 7. 0 to less than 7. Next, for bases, the pH is 7 to less than 14. For neutral substances or neutral solutions, the pH is exactly 7. The pH is exactly 7. Now, see this one. So, pH varies in between 0 to 14. For if the pH is 0 to 3, they are considered as the strong acids. If the pH is in between 12 to 14, they are considered as the strong bases. See this one. For 7, it is neutral. If the pH is exactly 7, it is neutral. If you move away from 7 towards the left side of 7, you will get all strong acids. See this one. 0 is strongest acid. 1, okay, stronger. You go on like this. See this one. This is the strongest acid. Next like this. Okay. But whereas here 7 is neutral, but 6 is pH. If pH is 6, it is the weakest acid. pH is 5, weaker acid. 4, weaker acid. Next 3 is stronger and strongest. Are you clear? Next one, if you move towards the right side of the pH scale, see this one, 7 to 14. If the pH is 14, if the pH increases, they are considered as the strong bases. Strong bases. See this one, when compared with 12 and 14, 14 is the strongest base. Okay, when compared with 8 and 14, 14 is the strongest base. When compared with 8 and 10, 10 is the strongest base. So, in the annual examination, they will give the questions, okay, related to the pH. See, remember that, see this one, more the H plus ions. If you find more H plus ions, the pH is less. Okay, less pH. Less pH in the sense, what does it mean? It is the strongest acid. Strongest acid. Are you clear? So, more pH is in the sense, it is the strongest base. Are you clear about that one? Now, come to the importance of pH in our day-to-day life. See, our teeth is made up of a coating, what is that? Enamel, okay, calcium phosphate. See, that is the strongest one, and that can be corroded by the action of acids produced inside our mouth. How the acids are produced? Because of the sweets and other food materials that stick to our mouth in the gaps of the teeth, okay, they germinate the bacteria and they produce acids. They began to damage the enamel present on the teeth. That is known as what we call it tooth decay. Tooth decay starts if the pH of the mouth is less than 5.5. Less than 5.5. Then what is the remedy for that one? You have to brush the teeth with the base. Toothpaste is nothing but base whose pH is 8, nearly 8 and more than 8. Okay, doctors advise, sometimes they advise the pH more than 8 also, Sensodyne like that. Okay, next come to the next one. See, for better yielding, for good crops, okay, see, we need the soil whose pH is very close to 7. Very close to 7. So, if the farmer tests the soil for its pH, if the pH is less than 7, it is considered as the acidic soil. Okay. If it is more than 7, it is basic soil. Are you clear about that? When he confirms it is the acidic soil, he treats the soil with the base. What is the base? He treats the soil with a quicklime. Okay. Next one, and calcium hydroxide and calcium carbonate. Next, if it is the, see this one, basic soil. If it is the basic soil, he treats the soil with decaying organic matter. Decaying organic matter like cow dung, like that. Are you clear? Next one, our human body also, it works at a narrow pH of 7 to 7.8. Okay, if it is less than 7, okay, there is a problem. If it is more than that, okay, there is a problem. Are you clear about that? So our pH, human body, for a healthy person, the pH of the human body is 7 to 7.8. 7 to 7.8. Are you clear about that one? Okay. We are discussing importance of pH. See, pH of aquatic life. See, the aquatic animals, aquatic species like fishes and other water living animals lives at a narrow pH of 6.5 to 9.0. Okay, 6.5 to 9.0. So acceptable range of pH of water living animals is 6.5 to 9.0. Are you clear? So sometimes the water pH decreases due to acid rains, due to industrial pollution and all other things. Okay, so during acid rains, the water rushes into the nearby lakes and water sources. Okay, they decrease the pH. So at that time there is a problem for the aquatic animals. For that one, what you have to do, you have to treat the water sources with calcium carbonate, which is a base. Are you clear? Next one, see this one, self-defense system of insects and plants. See this stinging nettle, it is a plant, okay, which gives, if you touch it, you will get burning sensation, okay, itching sensation. So because it produces, it has, the stings has, the beetle stings leaves has methanoic acid, okay, they secrete methanoic acid, that is COOH, which is known as, what we call it, formic acid. Sorry, this is formic acid. Okay, they secrete formic acid. Are you clear? So it gives us some itching sensation. Okay, next one, the bees, ants also. Okay, they also produce, what is that? Formic acid, HCOOH. Okay, because of that only you are getting some itching sensation and burning sensation. But whereas in the case of wasp, do you know the meaning of wasp? Kandrigantam. Wasp, it produces, wasp sting consists of alkaline. It is a base, it produces base. When you have wasp sting, okay, wasp bite, what you have to do, you have to treat with the vinegar, because it is a base, you have to treat with mild acid. Whereas in the case of formic acid, that is the bite of bees and ants, their sting consists of, that is formic acid. Okay, so you have to rub with the toothpaste or mild base. Are you clear? That is the remedy for that one. So this is the importance of pH in our day-to-day life. Okay, next another thing, see this one here, I will show it. This is universal pH paper. Universal pH papers. See this? Here, observe this one. When you test the given solution with a universal pH paper, if you find the color of the paper, this one, okay, its pH is, approximate pH is 1. Okay, if you find orange, its approximate pH is 3. If you find this color, its approximate pH is 5. If you find this color, its approximate pH is 6. Like this. Okay, for different strengths of acids and bases, it gives different colors. Okay, shall we test with the universal pH paper? Okay, we have few solutions with us. This is acetic acid. What is this? Acetic acid, which is a weak acid. See, I am testing with acetic acid. Observe the color. To which color it is nearer? Orange. Okay, its approximate pH is 3. Approximate pH, not accurate pH. Approximate pH is 3. Next one, see this. hydroxide. Potassium hydroxide. Observe this. Where is it? See this? It is very nearer to it. Observe this one. Observe this. Okay. It is nearly 12. Okay. Approximate pH only I am telling, not accurate pH. So its pH is nearly 12. Okay. Nearly 12. So potassium hydroxide pH is 12. Okay. Next one. I am testing with what is this? Right, this fellow, king of chemicals, sulfuric acid. Sulfuric acid. Observe this. To which color it is very nearer? What is the color? It is red, I think. Am I correct? Okay. So more than, what is that? Its pH might be in between 1 and 3. 1 and 3, maybe 2. Are you clear about that? So with the help of this universal pH papers, we can know the approximate pH of the given solution. Are you clear? Do you understand the concept? Okay, right. Thank you.